When galaxies collide, the cosmic events no one talks about. The night sky appears calm, eternal, a dome of countless stars glimmering as if frozen in time. For thousands of years, humanity has looked upward and believed in permanence. Constellations seemed fixed, galaxies appeared motionless, and the heavens gave the illusion of stability. Yet this perception is not only misleading, it is profoundly false. The universe is not still. It is in motion, restless, alive with forces so vast that they dwarf imagination. Every star, every galaxy, every cluster is moving, pulled and pushed by gravity's invisible hand, tracing paths that will, in time, lead to inevitable collisions. What is rarely understood is that galaxies, those immense cities of stars, gas, dust, and dark matter, are not static ornaments of the cosmos. They are dynamic entities, constantly shaped and reshaped by their neighbors. Some glide past one another, their edges brushing in fleeting encounters. Others slam together in violent mergers, tearing themselves apart and reassembling into entirely new forms. These collisions are not rare exceptions, they are the rule. They have always happened and they always will. And soon, in cosmic terms, our galaxy will be caught in one. The Andromeda galaxy, faintly visible to the naked eye on clear nights, is not drifting serenely in the distance. It is hurtling toward us at astonishing speed. Calculations show that in roughly 4 billion years, it will crash into the Milky Way, setting into motion a chain of events so vast that words like destruction and creation begin to blur. The universe has staged this encounter long before humanity ever existed, and its outcome is certain. We are passengers aboard a galaxy whose fate is sealed, heading toward an impact with a neighbor of equal magnitude. But what does it truly mean for galaxies to collide? What happens to the billions of stars, the fragile planetary systems, the black holes at their hearts? Do worlds like ours perish instantly, or do they survive in new orbits around alien suns? And what would the sky look like to any civilization alive during such an event? These questions are not science fiction. They are grounded in observation, in simulations, in evidence gathered from countless galactic collisions already seen across the cosmos. And yet, despite their reality, they remain strangely absent from our collective imagination. We speak often of asteroids, of climate change, of the fragility of Earth, but rarely of the fact that our entire galaxy is mortal. The silence surrounding these cosmic encounters makes them all the more haunting. Across the universe, telescopes capture galaxies locked in combat, their elegant spiral arms shredded into tidal tails, their stars flung into intergalactic space like sparks from a fire. We see their shapes distorted, their cores ignited in bursts of furious star formation, their black holes spiraling inward until they collide with unfathomable power. Each of these events is a vision of our future, a preview of what awaits the Milky Way. And yet, when we look at the stars above, we imagine stillness, order, eternity. This illusion shields us from a deeper truth. The cosmos is a place of impermanence. Nothing endures unchanged, not even galaxies. The coming collision between the Milky Way and Andromeda is not the end of the universe, but it is the end of the sky we know. For any beings who survive to witness it, the heavens will transform into a theater of overwhelming beauty and terror. Night after night, Andromeda will grow larger, brighter, until it dominates the horizon. Streams of stars will stretch across the heavens, new suns igniting, old ones consumed. Entire constellations will vanish as the patterns we know are ripped apart. The world we take for granted will be gone, replaced by a vision of creation through destruction, of birth through collapse. This is the paradox of galactic collisions. They are cataclysmic and yet profoundly creative. They destroy structure but forge new stars. They erase familiar forms but give rise to galaxies of unimaginable scale. They remind us that the universe is not a place of permanence, but of transformation, a vast cycle of death and rebirth played out on timescales that make human history feel like a fleeting breath. To understand these collisions is not only to glimpse the future of our galaxy, it is to confront the essence of existence itself. Nothing lasts forever, but in endings lie beginnings. As we descend into this story, We will explore the hidden dynamics of galactic motion, the forces that shape their destinies, the violence and beauty of their encounters, and the ultimate fate of our own Milky Way. We will ask what happens to worlds, to civilizations, to life itself when galaxies collide, and we will uncover why these cosmic events, though rarely spoken of, may hold some of the most profound lessons about who we are, where we come from, and what it means to live in a universe that is never still. Before we continue, remember this: most channels will tell you to subscribe for entertainment. But here, subscribing means something more. It means joining a journey into the mysteries no one dares to talk about, a search for truths hidden in the silence of the universe. If you're ready to question the illusion of permanence and see the cosmos as it truly is, subscribe now. The journey has already begun, and you are part of it. The hidden dance of galaxies. Every galaxy you see in the night sky is not fixed in place. Though they appear frozen, suspended like jewels in the blackness, they are in constant motion, guided by gravity on paths so vast and slow that human eyes cannot perceive them. The Milky Way itself is not stationary. It races through space at hundreds of kilometers per second, part of a larger structure known as the Local Group, a family of galaxies bound together by invisible threads of gravity. To imagine these motions is to realize that the night sky we know is only temporary, a snapshot in a film that has been playing for billions of years. Galaxies are immense, but they are not solitary. They drift in clusters, bound into groups, moving and colliding, their destinies intertwined. In the Local Group, the Milky Way and Andromeda are the giants, spirals of roughly equal size. For now, the distance between them is more than 2 million light-years, but distance in the cosmos is deceptive. When measured against the timescale of galaxies, this gap is not security. It is the space before collision. Andromeda is moving toward us at extraordinary speed, more than 100 kilometers every second. With each heartbeat, the distance closes, invisible to us but undeniable. This gravitational attraction is not unique. Across the universe, collisions between galaxies are common. Telescopes have captured their chaotic aftermath, spirals shredded into warped shapes, tidal tails of stars stretching tens of thousands of light-years into the void, luminous knots of new stars igniting in bursts of brilliance. Astronomers studying these interactions have discovered that collisions are not accidents. They are written into the architecture of the cosmos. Gravity ensures that galaxies do not drift forever. They are drawn together, merging again and again, forming ever larger systems until, in the distant future, entire galaxy clusters will collapse into single, enormous structures. But to understand what is coming, we must first understand the nature of these cosmic dances. Galaxies are not solid objects. They are mostly empty space. Stars are separated by such immense distances that even in a collision, direct impacts are rare. Two spirals can pass through one another, their stars weaving in and out like smoke, and yet the force of their gravity reshapes everything. Gas clouds crash together, triggering explosions of star formation. Dark matter halos interlock, binding the galaxies more tightly until they merge into one. The result is a transformation. New stars, new shapes, new galaxies born from old ones. This hidden dance is happening everywhere. The Hubble Space Telescope has revealed colliding galaxies in exquisite detail. The antennae galaxies locked in combat, their spiral arms torn into luminous streamers, the Whirlpool galaxy feeding on its smaller companion, galaxies twisted into rings, arcs, and shapes so strange they seem impossible. Each one is a preview of our own fate. For what we see in them, others will one day see in us. The Milky Way, that symbol of eternity stretched across our skies, is not immune. It too will collide, merge, and transform. The thought is unsettling. We look at the Milky Way as our home, the backdrop to all of human history, the constant against which we measure time. But this constancy is an illusion. The Milky Way is in motion, its arms stretched by invisible tides, its stars pulled in directions we cannot feel. And at its edge, Andromeda grows ever closer, its faint light a warning of the encounter to come. If civilizations exist elsewhere in our galaxy, they too must live with this knowledge, understanding that their skies are not fixed but destined to be torn apart. Why does this matter now, when the collision lies billions of years in the future? Because it reminds us of a profound truth. The universe is not stable, and our place in it is never permanent. To see galaxies as dancers, locked in orbits that will end in collision, is to confront impermanence on the grandest scale. And it is to recognize that even the heavens above, the stars we count on as eternal, are only passing patterns in a much larger story. As we begin this journey into the mystery of galactic collisions, we must let go of the illusion of stillness. The sky is not still. It is moving, flowing, reshaping itself over time. Galaxies are not frozen. They are restless. And in that restlessness lies both destruction and creation, endings and beginnings. The dance is already in motion. We are part of it, whether we acknowledge it or not. The violence of collisions. When two galaxies meet, the event is neither gentle nor fleeting. It is a clash of unimaginable scale, unfolding over hundreds of millions of years, where gravity becomes the architect of chaos. To grasp this violence, imagine the sheer size of what collides. A galaxy is not a single body, but a swarm of hundreds of billions of stars, each surrounded by planets, moons, and debris, all drifting within a vast halo of gas and dark matter. When two such swarms collide, the forces unleashed do not simply reshape one or two systems, they transform everything. The first stage is distortion. As galaxies approach, their gravitational fields stretch each other into strange, elongated shapes. Spiral arms bend and warp, stars are slung outward into colossal streams called tidal tails, and entire clusters are pulled free, drifting into intergalactic space. From a great distance, this looks like two elegant structures unraveling into chaos, but within, the effect is far more destructive. Planetary orbits begin to shift, gas clouds collide at enormous speeds, and dormant regions ignite with star formation. What was once stable becomes volatile. The second stage is ignition. When gas clouds crash together, their contents are compressed into starburst regions, birthing new suns at a rate far greater than normal. These newborn stars shine brilliantly, but their lives are short, burning out in only a few million years. Their deaths come in violent supernovae, scattering heavy elements into space. Collisions, then, are paradoxical. They destroy stability, but also generate creation. Entire generations of stars are born and die in the wake of galactic violence. Without such collisions, the universe would not have the same richness of elements that make planets and life possible. The third stage is consumption. At the heart of nearly every large galaxy lies a supermassive black hole, millions or billions of times more massive than the Sun. When galaxies collide, these central black holes are drawn together, spiraling inward in a dance of destruction. As they consume matter, they flare into quasars, releasing more energy than all the stars in the galaxy combined. To distant observers, these mergers shine as some of the brightest objects in the universe. To those within, they are catastrophic. Stars that wander too close are torn apart, their matter stretched into luminous streams before vanishing into darkness. And then comes the final stage, the merger. After passing through each other, the galaxies do not separate. Gravity binds them, dragging them back into repeated collisions until, over time, they coalesce into a single entity. Spirals merge into a vast elliptical galaxy, their original shapes erased, their histories written into one. In this final structure, order emerges from chaos, but it is a new order, fundamentally different from what came before. The galaxies that collided are gone, replaced by something greater, born of their destruction. This cycle of distortion, ignition, consumption, and merger is not rare. It is a universal process happening in every corner of the cosmos. Astronomers have documented countless examples. Galaxies twisted into rings, others stretched into arcs, some appearing shredded beyond recognition. The antennae galaxies show the elegance of tidal tails, the mice galaxies, the raw violence of stars being ripped apart. Each one tells the same story. Collisions are not exceptions to cosmic order, but its very engine. and yet, this violence is not easily understood from our perspective. To us, violence means suddenness, a crash, an explosion, an end. Galactic collisions, however, play out over hundreds of millions of years. From the view of a single civilization, they may seem almost motionless, the sky slowly shifting as stars migrate across the heavens. Generations would live and die without seeing the full event. Yet in the scope of cosmic time, the violence is absolute, leaving no part of a galaxy unchanged. For civilizations caught in such collisions, survival would depend not on their strength, but on chance. A planet flung into intergalactic space would become a frozen wasteland. Another might plunge toward a star. Some might endure, orbiting quietly as the galaxy around them transformed. The fate of entire worlds rests on gravitational dice, rolled without concern for the fragile lives they affect. Collisions are brutal reminders that permanence is an illusion. They reveal that the universe is not static, but restless, and that even the grandest structures are destined for upheaval. Yet they also remind us that destruction and creation are inseparable. Without these collisions, there would be fewer stars, fewer planets, fewer chances for life. The universe we inhabit is the product of violence, sculpted by forces that care nothing for survival, but make survival possible all the same. The violence of galactic collisions forces us to rethink the cosmos, not as a place of stability, but as a place of endless transformation. It is in the shattering of galaxies that new worlds are forged, and in the chaos of destruction that life finds its raw materials. For every collision that ends a structure, another begins. This is the paradox at the heart of the universe, that the same violence which destroys also creates, and that beauty itself is born from chaos. Black holes, the titans of mergers. At the heart of nearly every galaxy lies a secret, a gravitational monster so powerful that nothing, not even light, can escape. These are supermassive black holes, weighing millions or billions of times more than the sun. To the galaxies that host them, they are not merely residents, they are anchors, shaping the orbits of stars, influencing the growth of entire systems, and driving some of the most energetic phenomena in the universe. When galaxies collide, these black holes do not remain idle. They become the central players in a drama that shakes the very fabric of space-time. The process begins long before the final merger. As two galaxies approach, their black holes drift closer, drawn together by gravity. At first, their influence is subtle, each one pulling on the stars and gas around it, destabilizing orbits, feeding on whatever matter wanders too close. These feeding frenzies can turn them into quasars, cosmic beacons so bright they can outshine entire galaxies. To observers across the universe, such collisions appear as sudden, blinding eruptions of light, powered not by stars, but by the voracious hunger of black holes awakening in the chaos of a galactic crash. As the galaxies continue to merge, their black holes spiral inward, caught in a deadly orbit around each other. They circle closer and closer, their immense masses dragging space-time itself into ripples. These ripples are known as gravitational waves, and they travel outward at the speed of light, carrying with them the signature of cosmic violence. For billions of years, these waves passed unnoticed, invisible to all. Only in recent years has humanity developed the technology to detect them, capturing faint tremors in space-time from black holes colliding hundreds of millions of light-years away. Each detection is not just evidence of theory, but proof that these titanic events are real, happening continuously across the cosmos. The final act of the merger is a collision of unimaginable scale. The two black holes, after spiraling together for millions of years, finally crash into one another, fusing into a single, larger entity. The energy released in this instant is staggering, radiating more power in a few seconds than all the stars in the observable universe combined. Yet this eruption is not light or fire, but gravitational force, a shuddering of the very fabric of reality that echoes across the cosmos. What remains after such a merger is something even more formidable, a supermassive black hole larger than either of its predecessors. This new titan continues to feed, shaping the galaxy that forms around it. In some cases, these black holes grow into giants billions of times the sun's mass, becoming the engines of quasars visible across cosmic distances. They are both destroyers and creators, tearing apart stars while also regulating the growth of galaxies themselves. Without them, the universe would look nothing like it does today. The implications for civilizations are sobering. If a world orbits a star too close to the chaos of a merger, it risks annihilation. Stars can be consumed, their planets shredded. Entire solar systems can be slung across the galaxy, their orbits severed by gravitational tides. For those further away, the danger may not be destruction, but transformation. The skies could ignite with quasars, flooding space with radiation, stripping atmospheres, and sterilizing worlds. To survive such an event would require extraordinary resilience or extraordinary distance. Yet there is also beauty in these cosmic catastrophes. Black hole mergers are not merely endings, but beginnings. They mark the transition from one era of galactic life to another, sealing the union of galaxies into a single new structure. Their gravitational waves carry the story of their violence outward, a message written into the universe itself, waiting for civilizations capable of listening. Humanity, in its infancy, has only just begun to hear these whispers, and in doing so, we are reminded of how much more remains unseen. Black holes are the titans of galactic mergers because they embody the paradox of the universe: infinite destruction paired with infinite creation. They are the darkest objects known, yet they are responsible for some of the brightest phenomena we can observe. They consume matter, yet they shape galaxies. They erase stars, yet they write their legacy into the very structure of space-time. And when galaxies collide, they are the final arbiters, deciding what remains, what vanishes, and what is reborn. To witness or even imagine their power is to confront the limits of human comprehension. We can calculate their mass, detect their waves, simulate their orbits, but we cannot fully fathom what it means for space itself to ripple, for time itself to bend, for light itself to be swallowed. In the drama of galactic collisions, black holes are the titans, the monsters, and the architects, forever reshaping the cosmos in ways both terrifying and sublime. The fate of stars and worlds. When galaxies collide, the stage may be dominated by vast black holes and tidal streams of stars, but the true drama plays out on a smaller scale, within the countless planetary systems scattered across each galaxy. For the stars themselves, collisions are less destructive than one might imagine. The distances between stars are so immense that even in the densest regions of a galaxy, two suns are unlikely to collide directly. Most stars glide past one another unharmed, their journeys altered but not destroyed. Yet for the planets orbiting those stars, the story is far more precarious. Worlds are fragile, their orbits easily unsettled, their stability dependent on delicate balances that collisions do not respect. As two galaxies begin their approach, gravitational tides stretch and warp their structures. Stars are drawn into elongated arcs, some pulled entirely free of their galaxies and flung into intergalactic space. For planets bound to those stars, this is a sudden exile, a cosmic banishment into darkness. A world cast adrift in the void would become a frozen husk, its oceans solidified, its atmosphere collapsing under the cold. Any life that clung to it would vanish in silence, unrecorded and unnoticed, just another casualty of gravity's indifference. Other worlds fare no better. As orbits shift chaotically, some planets are dragged inward toward their suns, consumed in fiery death. Others collide with neighboring worlds, shattering into debris that glows briefly before fading into dust. And some, impossibly, may survive but find themselves captured by alien stars. Imagine a planet that once circled a familiar sun, torn from its orbit and caught by a star of another galaxy, rising into skies transformed by alien constellations. For any beings who lived there, the night would become unrecognizable, their sense of home shattered in a single cosmic upheaval. Civilizations, if they exist in galaxies caught in collision, would face unimaginable challenges. Their skies would shift over generations, constellations unraveling, new stars appearing, familiar patterns dissolving. At first, the changes might be subtle, a slow drift detectable only with careful records. But over time, the transformations would become undeniable. For those civilizations advanced enough to understand, the knowledge would be both terrifying and awe-inspiring. They were living through an event that would reshape their galaxy forever. For those less advanced, it might appear as divine upheaval, a rewriting of the heavens beyond comprehension. Yet destruction is not the only outcome. Collisions also give birth to new stars, ignited in the violent compression of gas clouds. Around these newborn suns, new planetary systems form, offering fresh chances for life. If civilizations are destroyed in one corner of a colliding galaxy, the raw materials for new civilizations are created in another. It is a cycle of erasure and renewal, death and rebirth written not on the scale of years or centuries, but of billions of years. The fate of stars and worlds in these collisions is not uniform, but scattered across possibilities: annihilation, exile, transformation, or rebirth. Our own galaxy will face this reality when the Milky Way collides with Andromeda. Though the odds of our sun striking another star are vanishingly small, its orbit will change. The solar system could be flung to the outer edges of the new galaxy or hurled toward its center. In one scenario, the sun might drift into quiet obscurity, circling the outskirts of the merged system. In another, it could be drawn into the dense heart, its planets torn away or destroyed in the chaos of starburst regions. For Earth, billions of years in the future, this may not matter. By then, the sun itself will have expanded into a red giant, erasing our world. Yet the broader lesson remains. No world is permanent. No star is truly safe. The fate of stars and planets in galactic collisions underscores the fragility of existence. We often imagine the cosmos as stable, our place in it as secure. But stability is a human illusion, born of timescales too short to perceive change. On cosmic scales, everything is provisional, subject to forces far beyond our control. Worlds that seem eternal can vanish in an instant of geological or astronomical time, erased by collisions that have played out countless times before and will continue long after we are gone. And yet, within this fragility lies possibility. A world destroyed in one corner of the universe may be replaced by another born in the aftermath of collision. Life, if it arises, may adapt, may migrate, may endure in ways we cannot yet imagine. The destruction of stars and worlds is tragic, but it is also the mechanism by which the universe renews itself. To understand this is to see the cosmos not as cruel, but as restless, always changing, always remaking itself through cycles of violence and creation. The fate of stars and worlds in galactic collisions is a reminder that permanence is not the law of the universe. Change is. And in that change, as brutal as it may appear, lies the reason we exist at all. Without collisions, without the chaos of disrupted worlds and ignited stars, the universe would be barren. It is in destruction that creation finds its place, and in the fate of stars that the story of life begins. The coming collision, Milky Way and Andromeda. When we gaze into the northern night sky on a clear evening, we can see a faint, elongated blur just beyond the stars of Cassiopeia. To the naked eye, it seems insignificant, a smudge barely perceptible against the vast blackness. Yet that faint blur is the Andromeda galaxy, the closest spiral to our own, and it is not a distant neighbor drifting away. It is moving toward us with inexorable speed. Astronomers have measured its trajectory with precision, and the conclusion is undeniable. The Milky Way and Andromeda are on a collision course. In roughly 4 billion years, they will meet in a cosmic embrace that will rewrite the night sky and reshape both galaxies forever. The scale of this encounter defies imagination. Both galaxies contain hundreds of billions of stars, vast clouds of gas and dust, and immense halos of dark matter that extend far beyond their visible edges. These halos are already overlapping, their invisible gravities pulling the galaxies ever closer. The motion is silent, steady, impossible to alter. Nothing in the cosmos will stop it, and nothing can. To think of galaxies colliding is to imagine chaos, yet the truth is more nuanced. While destruction is inevitable for some worlds, the encounter will also ignite creation on a scale unseen since the earliest ages of the universe. As Andromeda approaches, the first signs will appear in our skies. Slowly, imperceptibly, it will grow larger. Generations of humanity may pass without noticing, but to civilizations that endure long enough, the change will be unmistakable. 1,000,000 years before the collision, Andromeda will stretch across the heavens, brighter than any star or constellation. Its spiral arms will be visible as arcs of light, its core glowing with intensity. To those who look upward, it will seem as though another galaxy is descending upon us, a vision both terrifying and sublime. When the galaxies first make contact, their outer stars will begin to mix, tugged into long, glowing streams that bridge the void between them. These tidal tails will stretch across the sky like rivers of fire, constellations dissolving as stars are torn from their familiar patterns. Worlds will be scattered, their orbits distorted, their destinies rewritten. In some places, the collision will compress gas clouds into starburst regions, birthing new generations of suns. In others, stars will be thrown into exile, cast into the intergalactic wilderness with their planets in tow. For any life that endures, the sky will become a canvas of unimaginable beauty, filled with streaks of light and sprawling arcs of stars that dwarf anything humanity has ever seen. As the collision deepens, the cores of both galaxies will spiral inward, each drawn to the other by their immense gravitational pull. Over hundreds of millions of years, they will circle closer, their stars weaving together into a chaotic dance. The Milky Way's familiar spiral will unravel, its arms twisted and broken. Andromeda will stretch and warp, its elegant structure shredded by tidal forces. Together, they will give birth to something entirely new, a vast elliptical galaxy that astronomers have already named MILKOMEDA. This single giant structure will be brighter, larger, and more massive than either of its predecessors, a monument to destruction and creation in equal measure. At the heart of this new galaxy, a final drama will unfold. The supermassive black holes of the Milky Way and Andromeda will spiral toward one another, merging into a single monster billions of times the mass of the Sun. Their collision will send gravitational waves rippling through the universe, echoes of their union detectable across cosmic distances. The merged black hole will become the anchor of MILKOMEDA, shaping its stars, feeding on its matter, and burning brightly as a quasar visible to galaxies far beyond. For Earth, billions of years from now, the fate is uncertain. By the time of the collision, our Sun will be nearing the end of its life, swelling into a red giant and erasing the world we know. Humanity, if it survives, will no longer live here. But the collision itself serves as a reminder of a greater truth. Our galaxy is not eternal. The Milky Way, which has cradled our history, our myths, and our sense of permanence, is already doomed to vanish, replaced by something entirely new. To imagine the coming collision is to glimpse a future that is both terrifying and awe-inspiring. It reminds us that even the grandest structures in the universe are not immune to change. The stars we see tonight will not always shine in the same patterns. The Milky Way itself will not always stretch across the sky. The future belongs to MILKOMEDA, a galaxy born of chaos, a testament to the restless nature of the cosmos. And yet, within this inevitability lies a kind of beauty. The collision is not a tragedy, but a transformation. It is proof that destruction and creation are inseparable, that endings give rise to beginnings, and that the universe in its violence is also profoundly creative. The Milky Way and Andromeda will merge not into nothingness, but into something greater, a galaxy that will shine for billions of years to come. The sky of the future. If civilizations survive long enough to witness the approach of Andromeda, their skies will transform into a spectacle beyond anything humanity has ever imagined. The night sky we know, with its familiar constellations and patterns, is temporary. It is a fleeting arrangement of stars, shaped by distance and perspective, destined to dissolve in the Great Collision. To understand the sky of the future, we must imagine time not in years or centuries, but in millions, even billions of years. On such scales, the heavens are not still. They shift, transform, and blaze with visions both beautiful and terrifying. In the earliest stages of the collision, the change will be subtle. Andromeda, now visible only as a faint blur, will slowly expand across the night. For thousands of generations, it will grow brighter, its spiral arms resolving into arcs of light, its core glowing with the brilliance of billions of suns. To eyes trained on the heavens, the shift will be unmistakable. What was once a smudge will become a galaxy filling the horizon. The sky will no longer be empty, but alive with the presence of another cosmic giant. As the galaxies draw closer, the transformation will accelerate. Stars pulled by gravity will stretch into tidal streams, glowing rivers that arc across the heavens. Constellations, once anchors of navigation and myth, will unravel. Orion, the Big Dipper, Cassiopeia, all the familiar patterns will dissolve as stars shift into new alignments or vanish altogether. The sky will become strange, alien, filled with structures no human imagination has ever recorded. For civilizations looking upward, it will be a time of awe and unease. The heavens themselves will testify to change on a scale too vast to comprehend. When the galaxies finally begin to overlap, the sky will ignite. From the surface of a surviving world, the night will blaze with the light of countless stars compressed into luminous arcs. Vast new star-forming regions will glow with blue intensity, outshining anything in the current Milky Way. Nebulas larger than entire constellations will stretch across the sky, painted in shades of red and violet, fueled by collisions of gas clouds that spark the birth of newborn suns. The night will cease to be dark. It will become a canvas of fire, beauty, and chaos. But not all of this beauty will be gentle. For some worlds, the flood of radiation from newborn stars and quasars will overwhelm atmospheres, stripping them bare. The same light that dazzles observers will sterilize entire planets, erasing the possibility of life. From the surface of other worlds, civilizations may watch as familiar stars vanish, flung into the void or consumed by black holes. To live through this era would be to watch the very fabric of existence torn apart and rewoven in real time. As the collision reaches its peak, the sky will no longer resemble anything known today. Andromeda's core and the Milky Way's core will approach one another, appearing as two radiant centers glowing in the heavens. Around them, countless stars will spiral in chaotic orbits, forming shapes that shift with every millennium. The view from Earth or any surviving world will be one of constant transformation, a living, breathing sky that changes across generations. Where once the night sky provided constancy, it will become a reminder of impermanence, a symbol of the universe's restless nature. When the galaxies finally merge into MILKOMEDA, the sky will settle into a new order. Instead of the thin ribbon of the Milky Way stretched across the heavens, the sky will blaze with the dense glow of an elliptical galaxy. Stars will be scattered evenly, filling the darkness with light. To those who look upward, it will seem as though the night has been replaced by an eternal dawn, the blackness consumed by the radiance of billions of suns. It will be breathtaking, but it will also be a reminder that the world they once knew is gone. For civilizations advanced enough to endure, this transformation may be more than a spectacle. It may be a challenge to meaning. Constellations, myths, and stories tied to the stars will dissolve, replaced by a sky that no longer connects to the past. The heavens, once guides for navigation, calendars, and philosophy, will become unfamiliar, alien, and unstable. To live under such a sky is to live in a world where even the stars cannot be trusted to remain. Yet in this impermanence lies wonder. The sky of the future is not a void stripped of meaning, but a revelation of the universe's true nature. It will show that creation is inseparable from destruction, that beauty can emerge from chaos, and that nothing in the cosmos is static. For those who witness it, the future sky will not be a loss, but a gift. A vision of transformation on the grandest scale. The sky of the future reminds us of a truth we often ignore. What we call permanence is only illusion. The stars are not eternal. The constellations are not forever. Even galaxies themselves are temporary, destined to collide, merge, and vanish into new forms. To accept this is not to despair, but to wonder. The sky of tomorrow, filled with fire and beauty, will be unlike anything we have ever known. And for those who see it, it will be proof that the universe, in all its violence, is also infinitely creative. The question of civilizations. When galaxies collide, the forces at work are vast and indifferent. Stars are slung into the void, planets are stripped of their orbits, and black holes awaken to consume everything that wanders too close. But beyond the physics lies a deeper, more human question. What happens to civilizations caught in these cosmic storms? For while galaxies are ancient and collisions unfold over billions of years, life itself is fragile, measured in fleeting generations. If intelligent beings emerge within colliding galaxies, their fate is bound to the violence of forces beyond their control. At first glance, the odds of survival might seem favorable. Stars rarely collide, and planets far from unstable regions could endure the gravitational turbulence. A civilization orbiting a distant star might live through the merging of galaxies with little immediate disruption. But survival is not merely a matter of avoiding destruction. It is also a question of stability. Orbits shift, radiation levels rise, skies transform. Worlds that were once secure may find themselves cast adrift or flooded with deadly energy. Even if planets survive physically, the conditions that sustain life may collapse. For civilizations advanced enough to observe the cosmos, the approach of another galaxy would not be a mystery, but a revelation. They would see their skies shifting, constellations dissolving, and an enormous spiral slowly growing brighter on the horizon. Over millennia, they would watch as tidal tails stretched across their heavens, as new stars ignited, and as their galaxy became increasingly unstable. To them, the collision would not be a sudden catastrophe, but a slow, unfolding prophecy. Imagine the impact on their culture, their myths, their sense of permanence. To know that their galaxy was dying, that their skies were temporary, might alter their entire philosophy of existence. For civilizations less advanced, the experience would be incomprehensible. Their skies would change in ways that seemed divine, constellations dissolving into unfamiliar forms, luminous rivers of stars splitting the heavens. Their myths would be rewritten, their gods reimagined, their identities reshaped by the transformation above. To such civilizations, the collision might be seen as a cosmic judgment, a renewal, or an apocalypse foretold. The heavens, once a source of stability and meaning, would become a canvas of chaos, demanding interpretation. But what of survival beyond myth and philosophy? For some civilizations, the collision could mean extinction. Worlds thrown into intergalactic space would freeze in silence, cut off from their suns. Others would be sterilized by radiation from supernovae and quasars born in the chaos of the merger. For these civilizations, there would be no escape, no time to adapt, only erasure. Yet for others, survival might be possible, not through chance but through ingenuity. Advanced civilizations capable of interstellar travel might escape doomed worlds, seeking refuge around stars less affected by the collision. They might migrate to newly born systems, forging new homes in galaxies still reshaping themselves. The possibility of civilizations enduring galactic collisions leads to a haunting speculation. How many times has this happened before? The universe is filled with colliding galaxies, their mergers playing out over billions of years. If intelligent life is common, then countless civilizations may already have faced these challenges. Some may have perished, their histories erased. Others may have survived, adapting to new skies and new worlds. A few perhaps may even have thrived, using the chaos of collision as an opportunity to expand, to explore, to redefine themselves in ways we cannot yet imagine. For us, the coming collision with Andromeda raises similar questions. By the time it occurs, humanity as we know it may no longer exist. The sun itself will be near the end of its life, swelling into a red giant. Yet if our descendants endure, if they colonize other worlds or expand into interstellar space, the collision will be their inheritance. They will live under skies ablaze with new stars, navigate galaxies merging into one, and face the challenges of survival in a cosmos that erases all permanence. To them, the collision will not be a distant prediction, but a lived reality. The question of civilizations and galactic collisions reminds us of the fragility of life and the enormity of the cosmos. It forces us to confront the possibility that our story, like all stories, is temporary. Civilizations may rise, fall, and vanish, but the universe continues, reshaping itself endlessly. And yet, within this impermanence lies hope. If even a fraction of civilizations can survive these collisions, then perhaps the universe is filled not only with death, but with resilience, with beings who endure, adapt, and thrive amid the violence of galaxies. For civilizations caught in galactic collisions, the sky itself becomes both a threat and a promise. It destroys, but it also creates. It erases, but it also renews. The question is not whether life can endure, but how it responds when the heavens themselves are torn apart. Lessons from the collisions we can see. The universe has already written the script of galactic collisions in the skies above us, and we are fortunate enough to witness their unfolding. Through the eyes of telescopes like Hubble, James Webb, and others, astronomers have captured scenes of galaxies mid-collision, frozen in time from distances of millions of light years. These cosmic theaters are not abstract predictions, but direct evidence of what happens when giants collide. They are lessons carved into the fabric of the cosmos, available for us to study if we are willing to look closely. Consider the antennae galaxies, located about 45 million light-years away. Once two majestic spirals, they are now tangled in an embrace that has stretched their stars into immense tidal tails resembling the wings of an insect. To the eye, it is hauntingly beautiful, streams of light arcing tens of thousands of light-years into the dark. But beneath that beauty lies violence. Clouds of gas within the antennae have slammed together, igniting a frenzy of star formation. Dozens of star clusters are being born in regions so dense with newborn suns that they glow with blinding intensity. If civilizations ever lived there, their skies would blaze with supernovae, their worlds scorched by radiation, their sense of stability shattered. Or take the Whirlpool Galaxy, known for its elegant spiral arms. This galaxy is devouring a smaller companion, its structure distorted into graceful arcs of light. At its heart, waves of star formation ripple outward, triggered by the gravitational dance of the merger. To us, it is a vision of order and symmetry, a cosmic painting of swirling arms. Yet that order is deceptive. Beneath the beauty lies disruption. Stars are being torn from their homes, new ones ignited, and countless worlds thrown into instability. It is a reminder that elegance and violence often coexist in the cosmos. The mice galaxies, stretched into elongated shapes, illustrate another lesson, that collisions are not quick catastrophes, but long, drawn-out processes. Their tails of stars stretch for hundreds of thousands of light-years, evidence of gravitational forces pulling them apart over millions of years. Watching them is like watching a slow-motion explosion, one that unfolds on a scale so vast that no single civilization could witness its beginning and end. It forces us to accept that cosmic violence often lies beyond the reach of human timescales. The Cartwheel Galaxy tells yet another story. Once a spiral, it has been struck by a smaller companion, its structure warped into a luminous ring surrounded by arcs of star-forming regions. The impact has triggered waves of creation, igniting stars in a pattern that radiates outward like ripples in water. To study it is to glimpse how collisions do not merely destroy, but also reshape galaxies into forms never seen before. From chaos arises symmetry, from violence arises beauty, and from endings arise beginnings. Each of these collisions provides a lesson about the future of our own galaxy. They show us the stages we will face: distortion, starburst, merger, and rebirth. They demonstrate that while destruction is inevitable for some stars and worlds, creation is just as inevitable for others. They reveal that collisions are not exceptions, but fundamental processes of cosmic evolution, shaping galaxies into the structures we see today. Without them, the universe would be static, sterile, and incomplete. But beyond the scientific lessons, there is something deeper in these cosmic visions. They challenge our perception of permanence. We look at galaxies as eternal, as monuments of order in a chaotic universe. Yet every image of colliding galaxies tells us that even these giants are impermanent. They bend, break, merge, and transform, their forms rewritten by forces they cannot resist. In seeing them, we are forced to confront the truth that nothing endures unchanged. Not stars, not galaxies, not even the universe itself. These collisions also remind us of the dual nature of the cosmos. To human eyes, they are breathtaking works of art, luminous patterns of stars and gas scattered across the void. To those who live within them, they are catastrophes, upheavals that erase civilizations and worlds. The same event that inspires awe in us could mean extinction for others. This duality, beauty from afar, destruction up close, defines the universe. It is indifferent to our perspective, but it offers us the chance to see, to understand, and to learn. The collisions we observe today are windows into our own future. They show us what will happen when the Milky Way meets Andromeda, when our skies dissolve and reform, when our galaxy is reborn into something greater. To study them is not only to predict our fate, but to recognize our place in the vast story of the cosmos. We are not outside of these processes. We are inside them, participants in a universe that is constantly remaking itself. In the luminous arcs of the antennae, in the symmetry of the cartwheel, in the distorted elegance of the mice, we see our destiny written in the stars. The lessons are there, waiting for us to understand. Destruction and creation are inseparable. Permanence is an illusion, and the cosmos is a place of endless transformation. The role of dark matter in collisions. When galaxies collide, what we see is only part of the story. The luminous arcs of stars, the glowing nebulae, and the blazing quasars are merely the surface of a much deeper process. Beneath the light lies a hidden framework, invisible to our eyes but essential to the drama. This framework is dark matter, a mysterious substance that outweighs all the visible stars and gas combined. Though it neither emits nor absorbs light, its gravity dictates the movements of galaxies, and in collisions, it becomes the unseen stage upon which the entire performance unfolds. Astronomers have long known that the visible matter in galaxies cannot account for their behavior. Stars in spiral arms move far faster than they should if only the mass of gas and stars were present. The solution is dark matter, an invisible halo enveloping each galaxy, extending far beyond its visible edges. These halos are vast, encompassing not only the galaxies themselves, but the space between them. When two galaxies collide, their dark matter halos are the first to meet, intermingling and binding the galaxies into a gravitational embrace long before the stars ever touch. In this sense, collisions are not just interactions of light and gas, but encounters of shadow. Dark matter determines the paths galaxies take, how quickly they merge, and what shapes they form when the collision is complete. Without it, the Milky Way and Andromeda might pass each other by, glancing in the night like strangers. With it, they are locked in a destiny that cannot be avoided. Dark matter is the silent hand that ensures the inevitability of cosmic unions. Evidence of this hidden role can be seen in systems like the Bullet Cluster, where two galaxy clusters have collided. Astronomers studying it found that the visible matter, the gas clouds and stars, had slowed and distorted during the collision, but the bulk of the mass had passed through unhindered. This unseen mass, detected only through its gravitational effects, was the dark matter. The Bullet Cluster is one of the clearest proofs that dark matter is real, and it shows us how collisions unfold not only in light, but in shadow. In the coming collision between the Milky Way and Andromeda, dark matter will play the role of architect. As their halos overlap, the galaxies will be drawn closer, their fates sealed by the gravitational tides of invisible mass. The shape of the merged galaxy, its size, its stability, and its long-term evolution will be determined not by the stars we see, but by the dark matter we cannot. To imagine the future sky without acknowledging this hidden framework is to see only half the truth. But the mystery deepens. What is dark matter? Scientists do not yet know. It may be made of undiscovered particles, passing through ordinary matter without interaction. It may be something stranger, a property of space-time itself. Whatever its nature, its presence is undeniable, and in collisions, its influence is absolute. It reminds us that the most powerful forces in the universe are often those we cannot see, and that our understanding of reality is still incomplete. For civilizations that survive galactic collisions, dark matter would remain invisible. They would see the visible effects: stars flung into space, galaxies merging, skies transforming. but the true architect would remain hidden. Only with advanced science could they begin to detect its influence, to realize that their fates were being shaped not by the stars themselves, but by an invisible ocean of mass. To comprehend this would be to glimpse the deeper structure of the universe, to recognize that the cosmos is not built on light alone. The role of dark matter in collisions challenges our perception of permanence and control. It reminds us that much of reality lies outside our senses, unseen but no less real. It forces us to accept that what we see, the stars, the galaxies, the heavens themselves, are only the visible surface of a deeper truth, and in that deeper truth lies both humility and wonder. For when the Milky Way and Andromeda collide, what we will witness is not only a clash of stars, but a merging of shadows. The arcs of light across the sky will be guided by forces we cannot see. The future of our galaxy will be written not only in the brilliance of supernova, but in the silent gravity of dark matter. It is a reminder that the universe is larger, stranger, and more mysterious than we can yet comprehend. And perhaps that is the greatest lesson of all, that the most profound forces shaping our fate are invisible, waiting to be understood. In the hidden hand of dark matter, we see not only the destiny of galaxies, but the mystery of existence itself, the ultimate fate of galaxies. To understand collisions is to understand that galaxies are not eternal. They are not fixed jewels in the sky, frozen in their spiral or elliptical forms. They are transient structures, subject to the same law of impermanence that governs everything else in the universe. Stars burn out, planets crumble, civilizations rise and vanish, and galaxies themselves follow the same path of creation, transformation, and eventual dissolution. The collision of the Milky Way and Andromeda is only one chapter in this larger cosmic cycle, a reminder that even the grandest structures are temporary. When galaxies merge, the result is often an elliptical galaxy, a sprawling, smooth distribution of stars lacking the delicate arms of spirals. Over time, star formation slows as the reservoirs of gas are consumed or expelled. The galaxy grows older, quieter, filled with ancient stars that burn dimly against the dark. This is the destiny of MILKOMEDA, the new galaxy that will arise from the collision of the Milky Way and Andromeda. For a time, it will blaze with newborn stars, ignited in the chaos of the merger. But eventually that fire will fade, and the galaxy will grow still. The skies of the future will shine not with vibrant blue stars, but with the steady glow of red giants and long-lived dwarfs. But even this is not the end. Galaxies exist within larger structures, groups, clusters, and superclusters, all bound by gravity. Over immense timescales, these two will merge. Clusters of galaxies will collide just as galaxies do, forming ever larger systems. The ultimate fate is not the survival of individual galaxies, but their absorption into colossal structures where their identities vanish. The universe, restless and unyielding, draws everything together until only the largest formations remain. The role of dark energy complicates this vision. While gravity pulls galaxies together, dark energy drives the expansion of the universe. Over billions of years, the expansion accelerates, pushing galaxies farther apart. Beyond our local group, galaxies recede so quickly that their light will never reach us. In the distant future, observers within MILKOMEDA will see no other galaxies at all. The cosmos will appear empty, silent, devoid of neighbors, even though they still exist beyond an unreachable horizon. For them, the universe will seem smaller, lonelier, its true scale hidden by expansion. This paradox defines the fate of galaxies. On one hand, collisions will continue, forging ever larger systems until clusters collapse into single giants. On the other, expansion ensures that those giants will be isolated, adrift in a darkening cosmos. The future belongs to galaxies that are both immense and solitary, glowing islands surrounded by an ocean of nothingness. The cycle of collision and creation will continue locally, but the universe as a whole will grow more fragmented, more obscure, its history increasingly difficult to uncover. For civilizations, the implications are profound. Those who live in the distant future will inherit a universe that hides its own past. They may never see evidence of the Big Bang, never observe galaxies beyond their own. The skies will tell them only of their local world, erasing the larger story of cosmic evolution. Unless they inherit the knowledge of earlier civilizations, they may never know that the universe was once alive with billions of galaxies visible to the eye of human telescopes. The cosmos will seem eternal, static, unchanging. The very illusion we now know is false. The ultimate fate of galaxies reminds us that knowledge itself is impermanent. What we can see now is temporary, a privilege of our time. We live at a moment when the universe is open to observation, when galaxies are still visible across vast distances, when collisions can be studied in real time. This window will not last forever. To look at the cosmos today is to glimpse truths that future civilizations may never know, truths that could vanish into darkness as expansion continues. And so, the fate of galaxies is not just a scientific question, it is a philosophical one. It forces us to ask what permanence means in a universe that erases everything, even memory. It challenges us to confront the possibility that our search for meaning is taking place in a cosmos where nothing endures unchanged. Yet it also offers a strange comfort. If even galaxies are temporary, then impermanence is not failure, but design. The universe is not broken because it changes. It is alive because it changes. The end of galaxies is not the end of wonder. It is the final proof that creation and destruction are inseparable, that every ending is also a beginning, and that even in the silence of the future, the echoes of cosmic collisions will remain, written into the very fabric of space-time. When we look to the sky, we see permanence where none exists. The constellations seem eternal, the Milky Way a fixed river of light. Yet the truth is far more unsettling and far more extraordinary. Our galaxy is not eternal. It is moving, colliding, reshaping itself in a dance that has played out countless times before and will continue long after we are gone. The collision with Andromeda is not a distant fantasy. It is our destiny, written into the very structure of the cosmos. And in that destiny lies a profound lesson. Nothing is still, nothing lasts forever, and yet everything transforms into something greater. The universe does not speak in words. It speaks in collisions, in ripples of gravity, in the births and deaths of stars. If we are willing to listen, we can learn its language. It tells us that destruction and creation are inseparable, that beauty arises from violence, that impermanence is not an end, but a beginning. To know this is to see the universe as it truly is, restless, alive, and infinitely creative. Most channels will end here by telling you to like and subscribe. But this journey is not about numbers. It is about perspective. Subscribing means choosing to see beyond the illusion of permanence, to embrace the mystery of a universe that is constantly remaking itself. It means joining a search for truths that many ignore, the truths hidden in silence, in darkness, in the spaces between galaxies. If you are ready to continue that journey, then stay with us. Share this story, not just with others, but with yourself, as a reminder that you are part of something larger than any world, larger than any galaxy, because the universe is already moving, the collision has already begun, and together, we will be here to witness it.